All right, I think we're live. Welcome to the channel. And in this live stream, I'm going to work on a functional programming language called just-func. I'm just creating it at the moment. And if you come here to look for the near reincarnation playthrough or working on the game, that have to wait a little bit because a lot of this video, a lot of the work I do on the side is kind of driven by what I need, say at work or at something else. And so on this, what you're looking at, this just function is one of them. Right? So the idea is to create a programming language that is homoiconic and also implementation independent. And I'll go over the details a little bit, but let's first say what is the main topic in this video, which is working on the JSON schema so that I can create a specification of the language and which can be validated. And another objective of that, or characteristics of the JSON schema is I want to make it extensible because this is a programming language, right? And I have run into a little bit problem with it and trying to, in the process of trying to figure out what's going, is there a way to solve it? So that's the main focus today. So without further ado, let's get started. So over here on the left-hand side, what you see is the GitHub repository I have is under just-len and called, well, just-func. So first, let me explain what is homoiconic. So homoiconic is a term that means the language can be, or the source code itself can be used as the input. Right, so it can evolve itself. The popular example of these is Lisp, and another example is Clojure, which learn or borrow a lot of the idea and build on top of Lisp. So that's what homoiconic means. And then as for implementation independent, it means that you can leverage or declare or define your program in a media that is just text, just strings, and then it can be used in multiple programming language environment, which it can be used to say evaluate the program or execute it or do some code generation. So an example is here that I have a Hello World REST API example. So this is loosely follow Open API. So this path is used to define the endpoint. So we have a hello endpoint, and then it's a get, and then have a parameter called name. And then the handler, that's where we are using this just-func by specifying a function called string. This is the same function as in Clojure, which will do string concatenation. So this will just get the print the string saying welcome to just-func, and then calling this function, this called param_get, and get the name, which it will goes to the parameters over here, and then get the value of the name and put it over here. And so the whole thing would become, say I'm making a call to this hello and putting a name as Homer, then it will say, well, it will return saying welcome to just-func, Homer. So that's how it works. So you just need to define it, and you can see this is just defined in the YAML file, right? And then the actual implementation of the REST API service, for example, is in Node.js, or it is in JavaScript, well, Node.js is JavaScript, and or in PHP or in Rust or in Go, doesn't really matter. And as long as it can understand the language just-func and it can interpret it, then it can use this source code and do the things that's needed. So that's how this works. So on the right hand side, so now let me just maximize this. So this is just a readme, and I have something created. It's very basic, well, or essentially very simple, because functional programming is actually pretty straightforward when you get a hang of it. And this is a JSON schema to describe that. And if you're not familiar with it, you can go to JSON schema and try to look, learn it. Is a great schema specification, and it's widely used. So definitely, if you don't understand it, I encourage you to go and take a look at it. So in the nutshell is that, okay, we define a entry point called just-func. So that is the entry point of the schema. And it is saying that, oh, it can be either functions or literals. So to keep things simple, let's look at the literals first. So the literal is very straightforward. It's just say, okay, the literal can be of type string, integer, number, or string. That's it. And then the functions, this just function will be one of the following. Basically, just one of the unary, binary, tertiary, and quadratic functions. So then it goes in there, it's saying that, okay, unary function can be, for example, not. Not is a function that change one value to another value. That's why it's called unary. And then for binary, like say for a function called equal, is a comparison. So compare if A equals to B, right? Other example would be say less than, or greater than, or less than equal to, or greater than equal to. Right, and then the third one, ternary operation, is, for example, if statement or let. So the let over here, it means in functional programming, say I'm going to write it using Clojure, and it looks like this. You let for say x equals to 3. Right, x equal to 3, and then over here, the third place is where you use define the additional statements that it will be using this variable x. Right, so saying, for example, I'm just making it up, say print x, then it will go ahead and print the value of x to the screen, for example. So that's why let is a ternary function. And so the key of this discussion is over here. You can see the binary, unary, and tertiary function will have a reference to the just-func over here. So the idea is that using this example again, each place over here can be a just-func expression itself. So for example, here, this is expression of just-func, and then the literal is also an expression of just-func. It's just that it's a literal defined over here. So that's how this works, right? So it needs to recursively reuse itself. So by itself like this is fine, right? And if we define everything, all the functions in our application, then we are done. We'll be good, right? However, of course, that's not how programming works, right? You define something basic, in other programming language, you have certain keyword, certain reserved words that the program defines, and then after that, you would have core libraries and your custom code to define additional functions, right? So the functions need to be extendable. So the problem is this. If I'm going ahead, let me start the setup right now to create a spec. Right. Let me create a spec and say JSON schema. Okay. And then let me create one more folder called my app. Okay, and then I need to create one more folder called schema. Okay, it's a little bit long, but it's needed. So my app.json.c, right? By the way, JSON-C is just meaning JSON with comment, because the regular JSON doesn't allow you to put comment in there, right? So when I'm defining this, using JSON-C is better because I can put in comments and make it easier to read, to understand what the code does, right? So this create a schema over here, and then let me create another function, another folder over here, the source. Okay, and then well, this one, let me call this one as my app. And this one is called my app spec, like that. So what it means is I'm going to write the application in the my apps JSON-C, and then this one under the schema one is where I extend the application. So to make the whole thing works, let me do the workspace settings, create workspace settings, say file matcher, JSON schema, file match, right? And then URL is saying JSON schema, and then just-func.json. Okay, and then the file match would be actually let me move this my apps up one level, so I have one less level to deal with, because the application itself, it could contain both things, the spec and other stuff, right? So and also I'm using this to test the schema or the result, so that's okay. So JSON-C, do it like that. Okay, so let me first set it with the just-func. Okay, so right now this has nothing, because in VS Code, this kind of things is not something that you will change, constantly. So what happened is the VS Code will check those and cache it. So even if you make the change, it won't have effect. And so let's see if it is working correctly. My app source JSON C. This should start working, but it doesn't. Let me think. Oh, of course. What I'm doing, I haven't used it yet, right? So I haven't used it yet. So what I really need, yeah, is defining this. So let me just copy this part over here. Okay, and then I'm going to use a schema. So first type, I will expect it is an object. We will first start with object, and then properties, and then let's say test. And then the type is a no, I don't need this type. I would just say reference. Then the reference will be JSON schema just-func JSON C. Let's see if the relative path would be working correctly. So spec my app, and then schema, and then my app back. Okay, let's reload again. And if things go fine, I should see the result. But I'm not. For now, to simplify things, let me copy this over here. So separate that. And then make sure all this is fine, is definitions. And just in case, let me also do this, because that's what I did. And it was working. Ah, damn it. What did I miss? Maybe not a slash, not the root. Damn it. Damn it. Do I have an example here? I don't have access to example. What did I miss? What did I miss? Let's take a look. Let's go back to here. Not that. I record. Oh, not this one. Dot. Let's try that. I have schema validation turned on, right? Oh, sure, it should. Yeah, it's on. This is still not working. Let me simplify the whole thing and just say that. Right, I didn't do any typo, didn't have any typo. There you go, this works. Okay, this works. So meaning is also the path problem. Let's see. Because why I'm doing this is I want to limit the scope so that it will able to test different version of a schema. So give it a little bit, give me a bit more time. It should be working. It's getting close. Damn it. How about, you know, say, because this is a single level. Right. Let's see. Yes, something's coming. Is something. Yes. So that yeah, yeah, let's just keep it like that as it is working. Right. So over here I have this test, and then the first selection allow me to do is false and true because it's part of the literal. So let me do one more test to get it all the way one step, and then JSON schema like that, go there, right? So reload, so that I don't have to copy the files over in multiple places. Yes, yes. All right, so then I can delete this file just in case. Reload it one more time. Show up. There you go. So do this test. So again, that's a true and false, and the reason is because of this, right? So true and false is a selection because down below there is a boolean, right? Number and string, there's no compression you can do because it's infinite, right? And the same as integer. I actually, you know, not sure do I need both, but it's okay to keep both over there. Then if I start an array, then I get all the completion over here. So all the functions or the function and or operator that's defined in this list. So if I do say, for example, equal, and then I can say equal 1 and 2, right? And then over here, I actually get a completion to show that, oh, I have I am pointing the right thing. The thing is, if I'm do this, and you can see, you know, this is incorrect, right? So it gives me all the completion that I need in the code, in the program. So now that is great, but now the problem starts, right? So what I want to do in this application is say for example, this is a REST API example. So let's say just redo the example over here. The example over here, this one, right? I want to create a REST API, right? So I'm not going to repeat the whole thing, but I'm going to show that because we have this function, right? This function is not part of the core function, all right, or core language. So I need to define this, right? So over here, how am I going to define it? Right. One way to do that is I can define it in this file, which is kind of also okay. Let me see. Should I do that? Yeah, let's keep it simple first. Let's do that. So I can define a definition. And in the definition, I can add that function in, and let's call just param get. Right, so this is a param get, and then it takes one parameter. Well, first of all, it is this syntax. That's what we are defining. This syntax is an array. Right, so we want to say this is an array. Right, and for array, you have items, and for items, the first entry is a string. Right, so the first entry is a string. Let me put this to, well, actually, over here, I have this over here. So yeah, I have this param get. Right, and then let me minimize that to give you a better view of it. So this param get. So this is a string, and then I can define it is a constant, and the value of the constant is param get. Okay, so that's fine. So I just in case I can add a description like that, to when you write program, you saw this, you see this description, you should know what it tried to do, right? Then the second parameter, and we only take two parameters, right? So let's also say the additional items is false, and the second parameter is also a string, right? So and then can be anything. It can be any string, right? So the description, well, essentially it's not really any string. It's a string that can be used as the identifier of a parameters. On the REST API, there's some specific requirement. You can use certain characters, but keep it simple, right? So name of the key, right? So with that, we have defined that function. So the next thing to do is how are we going to let the schema knows is that will work, right? So one way, let's start with the easiest way, although it won't work, and first that's what we will try to do here, is doing one-off, right? It can be one of those, the built-in functionalities, or it can be a reference to this definitions, just param get. Okay, so with that, let's reload the code. Right, reload VS Code. So now over here, this is still working, right? And then over here, I can actually pass it in. I don't know why it doesn't show the other one. Actually, that's kind of strange, right? So over here, I can do this, say name, right? If I do something else, it get the same thing. It will return fail, right? So but what if I do this? Right, this is still good, but how about try to do this whole thing, right? So this welcome to just-func, and then if I just say say Homer over here, this works fine, right? It just okay. However, if I do this, right, I get the completion of these things, the built-in functions, but if I do param get name, this doesn't work. Right. The reason of it doesn't work is this, because when we are inside here, right, we are calling this function, which is defined as a periodic functions over here is a string, right? So in this definition, it say the additional items has to be a just-func, and our code, the just param get, is not part of the just-func, right? That's why it failed. If I put over here, if I put the some of those other functions like 1, 2, right, this is okay, this is fine, but I cannot put this in there, right? So that's the problem. That's the problem we try to solve, right? So the first solution, so let me keep it really dumb. The very first solution is just copy this whole thing over, right? So this is the specification of the just-func, and instead of referencing it over here like that, I'm going to just copy them over. And so now this is let me comment this out and say ref definitions just-func. Okay, it's refing the just-func over here, and then in this just-func I can add the reference, add the new function that I defined. So just param get, because now this is local over here as I defined it over here. So with that, if we reload it, you see that now it works. Okay, so far so good, great. But then it's not really usable in this state, right? Because then if I wrote one program like this, and then another program, and then another program, and so what happened is each of them copy their own definition of the just-func. So later on, if just-func evolve and add some new functions or change the schema to add stuff, then all those applications will not get the changes, right? That's not what we want. Right? So can we do better? That's when it gets to here. So one problem, well, that's the problem. That's why I create a GitHub issue over here to saying that we couldn't override the ref, right? So the rationale is that in this, instead of copying, right? So let me, I cannot Control C because I reload the whole window. So let me take this out, right? Take this out, put this back in, right? The real issue is, the reference, as I showed, this reference are the problem. So I was thinking, is there a way to override them? So if I override them, if I able to override them over here, say I the proposal I was thinking of is say something like this: override, and then in the override I said, oh, if the for this guy, well, actually over here, for this guy, if we encounter this reference, right? If we encounter this reference, then let's change it to our own reference. So say our just-func. So in that case is we can define our just-func over here, and then it will be one of the kind of this just-func, and then this guy, right? Essentially that. And then so over here, this go back to the other way, to same reference, just-func, like that. And ideally, if this is supported, then this will work. Although it's still a little bit messy, and but you know, it's one way to make that happen. So that's why I created that this issue, because I couldn't find a solution. But then after some discussion, you know, when I try to understand and look for a solution, mentioned that I saw, you know, also saw this. So this is the later draft, one of the newest draft. You can see that this is very new. This is actually 2020 December draft, and it has this dynamic reference. Okay, and also this dynamic reference and this dynamic anchor. In the 2019 version, it is called recursive reference and recursive anchor, and in the 2020 version is renamed to this dynamic reference and dynamic anchor. There might be some additional detail, you know, about the difference between the two. We're not going to go into that because I don't know. I just looked this up and try to learn along the way. Right, so this they're saying might work. So what I have is I create some examples over here and then see if that will make this work. So that's what we are going to do. All right. So for the first attempt, so the idea, so let's first explain what they are. So in this draft, you know, need to make it really big. I know, you know, this is kind of dry and hard to understand, like, and you know, as with most specification, I have hard time understanding this. But of course, it's not their fault. It's, you know, this kind of documentation is how it is, and after I read it a couple times, it's actually not too bad. I agree, and they actually did a pretty good job, right? So thank you for creating a nice specification that's kind of easy to understand. And let's see. Yeah, actually, let's go over this in detail so that we make sure you know, you get a chance to understand what this does. So let's read it through. Consider the following two schemas describing a simple recursive tree structure where each node of the tree can be a data field. The data field is not actually important in this example. The first schema allows and ignores other instance property. The second is more strict and only allows the data and children property. An example instance with the data is misspelled as DAT, as is also shown. So what this means is that we have two schema. One is called the tree over here, the tree schema, One is called a straight tree, which based on the tree schema. So how it works, so let's take a look at the tree schema first. Okay, so the tree schema is, forget about the anchor, so that we understand the overall structure first. So it has an ID, saying that this is example.com/tree. And that's why when we're doing this reference, at least what I'm describing is how I understand it. I might have made a mistake and what I'm saying is completely wrong, but that's why I understand at this moment, right? So actually I think I'm a little bit too loud. Readable go? Okay. So this is the ID of a tree, of this tree schema, and then it is an object with the data property, and then also have a property called children, and it is an array. The children is an array. So let's see. Let me do this. So that we can kind of play along. So let's create a JSON C. So this means, this is describing the document is an object, right? So over here, this is an object, and then actually I hope this will work a little bit better. Yeah. So this is an object, and inside it, it has it can have a property called data. Right, and then it can be anything. That's how I understand this true, but it's not important, right? So let's say also say it's true, but in here it's using 1, so that's okay. And then it also have a property called children. Okay, and then this children, the type is an array. So this is an array. Right, and the items in there is a reference to this pound note, as you saw in the typical JSON schema. The pound is a reference to the document, right? The things inside the document. When there's nothing before the pound is a local reference. Right? I wrote it with a slash, and over here this doesn't. This is just saying pound note, and you notice that there is no note defined over here. So normally, if I copy, let me copy this over here. So normally, if we define this without this dynamic schema thing, you need to define something like this, a note over here, and then this define what it is, and so on, right? So, but for this dynamic reference, is from my understanding, it was saying, okay, I'm referencing this anchor, and this anchor is describing this object, because that's where the anchor is defined at the top level, right? So therefore, the data, the object or the entries inside this children array, it can be a tree, right? So is an object. It can have data equals to 1, and then it can have children, right? And then is an array itself, and then recursive, right? You can have multiple of the same thing, right? And so on and so forth, right? So that's what this tree schema describes. Okay. Then let's take a look at this straight tree schema. So it's referencing the tree over here. So this, because they are they have an ID, both have an ID start with https example.com. To my understanding, this ref tree will find https:/example.com/tree. That's how it references this file, right? This schema. So this line is saying my whole thing, this object, because just like over here, the top level, this type object is defined the outermost piece of the JSON, right? And in this case, this defined it is an object, so that's why we have this object over here. And then here is saying that this whole thing just take that it references that tree, so it is also an object just the same, right? And the only difference is over here it have this unevaluated property set to false, meaning if you have extra fields, I'm going to complain. I guess this is similar to the additional properties equals to false things that I said. We have these additional items, and then for objects there is also additional properties, right? So maybe for the, you can see that this unevaluated is not here. And well, before I say that, let's make sure. All right, yeah, it's not here, right? So it might be something new, or might be a rename. This unevaluated property is a rename of this additional property in the new draft. So yeah, so I take that as what the face value, what it means. So this, again, back to here, this strict tree, what it does is say it getting the tree in schema, and on top of it is saying unevaluated property equal to false, right? So with that is Able is trying to mandate or change the behavior or add behavior on top of this tree schema. All right. So then how does it deal with this self-reference, right? Because if we don't do anything, or if this, let me go back to here, right? If this is just a reference, and then this node getting say this is somehow the root, right? Something like that, then it will have exactly the same problem that I have, because now in there the things that this reference it has in here will be the tree schema itself, and not the straight tree schema. So meaning over here at the very top level, if this is controlled or this is validated against the straight tree schema, if I add a full equals to 1 here, the straight tree schema will fail the validation and say that, hey, you should not have extra properties, right? But if I'm doing it in here, the second level, this one over here, because the tree schema over here is referencing itself, then it's actually referencing this tree schema. So if I'm going to add this over here, it will work. It will pass, because that is wrong place. Wrong place. Here. Right, like that. So this will pass this straight tree schema validation, because over here this reference is referencing tree instead of straight tree. So the dynamic reference and dynamic anchor, what it does is that saying, okay, over here I'm doing a dynamic reference instead of a regular reference, and then I mentioned that this is a dynamic anchor here. And over here in the straight tree schema, I'm also referencing, hey, this one I'm defining right now is also use name or anchor as node. So when we go into this level and try to validate against the schema, the validator will go to here and and see that this is a dynamic reference of this node anchor. And instead of getting this one, the anchor is overwritten here. So it would pick this one instead. So that solves this problem, right? That's how I understand, this dynamic reference and dynamic anchor works. All right. So with that said, let's go back to our code. Say cancel. So now we're going to implement what I have over where did I go? Over here. Implement what my attempt is and see if that works. But keep in mind that this might not work at all, because at least in the IDE in VS Code, because the specification is so new that there's a high chance the VS Code schema validation have not updated implementation to support this. Right. So, but we're going to give it a try. But before we do that, since we have streamed for about 15 minutes, let's take a break and continue in the next one. So again, let's wrap up. And so in this video, what we did is we described what the problem is, and then also give a attempt to explain what this dynamic reference and dynamic schema does. And hopefully it's correct. I think it should be right, my understanding, and hope that my explanation would help you. So with that, let's end this session and we will continue in a bit. Bye.